In this video, I'm going to show you how to do a non-pairwise comparison. And it's based on the Masters data, which is continuously scored data, and three groups. We've got Masters, Light Masters, and Spacers. So Masters are one category that you might conceptualize, and Spacers are their own category. And so you might want to test the difference between these two means combined against the Spacers mean. And the way we can do that is through the contrast analysis utility. First, you would check to see your normality issues. So I'm just going to do that right now, normality and outliers and such. So I'm just going to quickly do that to make sure that we don't have any issues there. And we have skew, kurtosis, well below 2 and 9 respectively. Skew and kurtosis. These are all acceptable levels of skew and kurtosis, less than 2 and 9 respectively. Distributions look good, and no outliers. I don't know about homogeneity of variance though, so let's check out homogeneity of variance through the regular one-way utility. I don't actually necessarily need homogeneity of variance to be satisfied, because I do have an option to test it without it, and we do have Levine's test of homogeneity of variance has been satisfied, so I can go ahead with the regular non-pairwise comparison. I need to specify the coefficients, so go into contrasts, and the way I want to test this is that it's going to be Masters versus non-Masters, and you would theorize that Spacers, according to the research that this study is based upon, or this example, Spacers perform better because studying in such a way that you split up your study time is better than cramming all the study time into the same period. So we'd expect this mean to be higher than these two means. And so we can specify those linear contrast weightings in this way. We expect the first group to be lower, and that's going to be combined. So we need to have a half weighting. So the first two means are going to be combined in a negative way, and such that they're hypothesized to be lower, and the third mean is supposed to be higher, and the coefficient total is 0, which is what it's supposed to be. Click on OK. Looks like something didn't. Yeah, that's all right. Click on OK, and we should look at the descriptive statistics, of course. And OK, and here we go. And we get the analysis here, such that this is the contrast group weighting here, negative 0.5 versus plus 1. And we can see that that contrast analysis is statistically significant. And if we look at assume equal variances, which we can because Levine's was not statistically significant, we get a t-value of 3.59 with 57 degrees of freedom and p-value of 0.001. And so basically, let me create a graph so that we can actually look at what we got here. And we'll look at the Masters in there and the grouping variable here. And you can see that this analysis makes sense because these two groups here are quite similar. They're lowish and these are higher. And basically the analysis is saying that these two means combined, averaged, are statistically significantly lower, the mean itself lower than this mean here. So that's how you can do a non-pairwise comparison if you wanted to do one. And as I've mentioned before, that sometimes it could be the most powerful way to analyze your data in some cases.